Hello! In this video, we're going to see how anynines handles primary failover for PostgreSQL instances with more than one replica. So here on my laptop, I have a Kubernetes cluster provisioned with kind, and it already has anynines installed and a PostgreSQL instance provisioned. Let's take a look at it. kubectl get pg, shorthand for PostgreSQL, sample pg cluster. Yep, there it is. And if we look at its full YAML, we should see that it has 3 replicas. And in fact, if we go to its spec, we see that the parameter replicas is equal to 3. And if we look at the status, we also see that it says that all of those 3 replicas are ready. We can verify the same thing by looking directly at the pods. So if we do kubectl get pod, we see that there are exactly 3 pods, 1 for each replica in our PostgreSQL instance. But what's the relationship between these replicas? They constitute what's called an asynchronous streaming replication cluster. To learn what it means more in detail, check the link to the PostgreSQL documentation in the description. Essentially, it signifies that out of the 3 replicas, there will be only one, called the primary, that will be able to serve write request, so modifying the data in the database, whereas all the replicas can serve read requests. When the primary accepts a write request and applies it to the database, the write is later propagated to the other 2 replicas, called secondaries. So you could say that the secondaries are copies of the primary with a certain delay. But given all this, how can we learn which of our 3 replicas is the primary versus which ones are the secondaries? The answer is via Kubernetes labels. So anynines attach a label with the role to each instance. So to see which is the primary, we can use the command kubectl get pod selector anynines replication role. This is a label key that all of our PostgreSQL instance replicas will have, equal to master to learn which one is the primary. And by doing so, we learned that the one called sample pg cluster 1 is the primary, so it's the only one that accepts writes request. Now at this point, let me take a moment to apologize for the use of the term master. We're aware it's non-inclusive and we will remove it very soon. Likewise, we can find out which pods are the secondaries, still by using the same label selector, but this time by using the value replica. Even though in this case it wasn't much of a surprise, since there can be only one primary, the other 2 replicas necessarily must be secondaries. So at this point, you might be wondering, okay, we know the primary is sample pg cluster 1, and it's the only one that can accept write requests. So does it mean that if that pod/replica dies for whatever reason, I can no longer write to my PostgreSQL instance, so my applications can no longer write to their databases? Well, the answer is likely no. Anynines does better than that. And let's actually see this in action. So we're going to simulate the death of our primary, for example, by using kubectl drain to mimic death of the node where it's running. So first we have to find out on which node it's running. kubectl get pod sample pg cluster 1 output YAML rep node name. Okay, we now know that our primary is running on a node called kind worker, and by node I mean Kubernetes cluster node. So let's actually drain it. kubectl drain kind worker, ignore daemon sets. I will explain this command in a moment. Okay, kubectl drain kind worker means drain this node, that is, evict all the pods running on it and make it unschedulable. This mimics the scenario, like I said, where the node crashes. And we don't care about the details such as these flags. So let's actually run the command. Okay, so this means that our primary pod just got evicted. That is, Kubernetes removed it from its node. So you might be wondering, does it mean that our primary is gone? Well, let's again run the same command we previously ran to get the current primary. kubectl get pod selector any8s any9s replication role equal master. Again, apologies. And now we can see that the primary is no longer the old one, sample PG cluster 1, but it's sample PG cluster 2. So what happened is that as soon as the old primary, sample PG cluster 1, died, any8s detected that the primary had died, and the two other replicas immediately elected a new primary among them, which means that even as the primary dies, a new one is read immediately so that your application can keep writing to the database. Another question you might have is, what happened to the old primary, right? Because while it's great that any8s immediately elected a new primary, our PostgreSQL instance in the spec has 3 replicas. So it means we always want 3 replicas to be running. But the old primary got evicted. Does it mean that right now we only have 2 replicas running, even if we'd like 3? And the answer is again, no. And we can verify this by looking at the pods that we have. If we do kubectl get pod, we can see that we have 3 pods up and running, 1 for each replica. So what happened as soon as the old primary, sample PG cluster 1, died, was not only that a new primary was elected among the 2 other replicas, but also that a replacement for the old primary pod was immediately created by any8s. However, if we now look at the labels that denote the replication role of each replica, we should see that the old primary, sample PG cluster 1, is now a secondary. It's no longer a primary. So it was replaced, but it came back as a secondary because a new primary had been already elected in the meantime to minimize downtime. So the final question we want to answer, and that you might be wondering, is this. It's great that as a primary dies, one replaces it immediately. But it also means that the identity of the primary changes, and this in turn means that the IP address of the primary changes. And we said that only the primary can serve write requests. So does this mean that anytime the primary changes, the applications that are writing to the database need to reconfigure themselves to use the IP address of the new primary, which will be different? This wouldn't be ideal because it would be a disruption, right? Luckily, the answer is still no. As far as the applications writing to the database are concerned, nothing changed. And the reason is that any8s exposes the primary not directly via its pod IP, but indirectly via a Kubernetes service IP. This is a standard Kubernetes mechanism, so we're not going to talk about it in detail, but it essentially means that any8s provides the illusion of a static IP address for the primary, even if the actual IP address changes. And in fact, we can verify that there is such a service that targets the primary by doing kubectl get service sample PG cluster master. And here it is. As you can find, there's this service. And this is the service associated to our PostgreSQL instance that always targets to the primary pod and redirects traffic to it, no matter which pod it actually is.